previous videos, we talked about the standard road section that we need to refer while producing the engineering plans. The standard road sections give you the specifications and dimensions of the road components for a given road reserve width. Depending the development areas where it is situated, you will need to refer to the relevant standards, which can vary from place to place or from state to states. The example that I showed to you is based on the state planning authorities of my own states. Different states may have different standards, and you should refer to the relevant documents accordingly. We also mentioned in our previous videos, specifically for this road standard manual, there are new standards and old standards. The top priority, it will be in accordance to the new standards. It is only when you have adjacent developed areas developed long time ago following the old standards, and you will need to have a proper connections for the footpath as well as the green verge. Then you may adopt the old standards. Therefore, we should keep track of the specifications of both new and old standards. Next is about how we're going to use the standard. You may refer to the specified width of the road reserve. There are various sizes, and then there are three main categories. Constructions of the entire road section of various sizes, constructions of the front service road of different sizes, as well as the constructions of the half road, either first half or the second half of various sizes. You will need to refer to the right category of the road section and produce your road sections accordingly. Now, if you observe the standards, it is specified that you will need to have pipes to be pre-embedded underneath the pavement with the minimum size indicated, which in this case 250 diameter minimum ductile iron service pipe are to be embedded underneath the road. The purpose here is to allow the passing of the services underneath the road, so that if we need to pass the services underneath the road, the services can go through the pipe without requiring any excavation routes of the constructed road. Now the question here is, where should we place this service pipe? Normally they put it at the road junction. It is also stated that at 300 meters intervals or at every road junctions. This depends on the local authorities. Previously, they do not really enforce this, but we do see some local authorities enforcing to have this service pipe well prepared to minimize the disturbance to the newly constructed roads. Next is about the curb. The curb is normally put along the edge of the road to restrain the movements of the vehicles out of the pavements. If in accordance to the standards, no curbs is required for a typical road reserve, you don't have to provide curb. The provisions of curb may be on the basis of the requests by the local authorities upon the submissions. As a designer, you may also decide whether to have the curb in place. Now, if you choose to provide the curb, you will need to clearly indicate where are the locations of the curb. Also, you will need to provide detailings for the curb in terms of the size and dimensions, as well as the reinforcement bars. And remember to provide opening for water to pass through, so that water can flow into the drain to prevent ponding of water on the road surface or along the edge of the road. Curb may be provided for the safety of the pedestrian using the footpath, especially when you're designing your road section to have a smooth surface between the pavement and the footpath. By having a curb here, probably this will be safer for the pedestrians walking along the footpath. Again, in the case that the road curve is provided, you need to provide opening for the water to flow into the drain. Under some circumstances, designer may choose to have the footpath slightly higher than the pavement, and the edge of the footpath here will be considered as the curb. This is another option. Now, if you choose to design in this manner, you will still need to provide openings for the water to flow into the drain. Normally, the drains are open drain, unless otherwise required by the local authorities. Now, when you want to design the drain, the width are normally specified. It depends on the catchment area as well as the design pit discharge. This shall govern the depth of the drain. There should be analysis so that the drain size is adequate to effectively discharge the water. Normally, there are minimum depth as specified by the local council. For example, for the normal drain, at least 600 mm depth. As for the perimeter drain, for the shophouses, the minimum depth it will be 1 meters. For this, you may need to refer to the submission checklist of the local councils. There are also other requirements, such as the minimum thickness of the drain, and in the case that culvert is required, the minimum thickness of the culvert is 150 mm. In the case that the drain's depth is more than 1.2 meters, safety rail shall be required to ensure the safety of the public. Taking this drain as an example, when the depth of the drain more than 1.2 meters, you will need safety rails at both sides of the drain to prevent the pupils falling into the drain, which can be dangerous. In old days, struts are allowed. Nowadays, struts are not allowed for all drains. This is the strut for the concrete drain. Nowadays, struts are not permitted. The concrete drain should be designed without any struts. I believe it is due to the safety issues as well as the maintenance issues. Very often we see the damages on the strut by looking at the reinforcement bar provided. Normally very limited reinforcement bars are provided to make the strut. You also need to understand that for a typical developed areas, normally the open space as well as the infrastructures such as the roads and drains, they are to be handed over to the local council, and the local councils are to do the maintenance in the case that there are any damages. You as the designer, or considering on behalf of the developer, your intentions is to minimize the cost for the constructions. This is so that you can maximize your profit. However, the local authorities, they are more concerned of the public safety as well as the long-term maintenance. Nowadays, even the open drain, during the submissions, they have the requirements not to use mild steel wire mesh as the reinforcement. Instead, they will require double layers of reinforcement for all drains. This is an example of the reinforcement bar for concrete drain. If you look closely the reinforcement bar, they are all high yield steel strength. You can see the ribs on the surface. And then there will be double layer of reinforcement. By looking at the size of the reinforcement, Taking this as an example, this will be the Y10 rebars, and this is most likely Y12 rebars, which can be quite heavily reinforced. For a typical drain of this size, this amount of reinforcement bars are provided. Normally is on the basis of providing resistance to the active pressures of the soil acting onto the wall of the drainage. Another reason is for the maintenance issue. If drains is designed properly, the local council do not need to spend too much effort or money to do the maintenance in case of any damage happen. What is interesting when you see the design, they use this as the spacer for the 2 layers of reinforcements of the concrete drain. As for the base of the drain, double layers is also provided. You may observe how they put their reinforcement. This gives you some ideas how to produce the detailings for the drainage. Due to the high effective depth here, you will need transverse reinforcement to control the cracks, the surface shrinkage crack. Another interesting thing is this reinforcement bar, which is placed in some form of arc along the spans of the drain. To be frank, I do not know what is the functions of this reinforcement bar. By looking at the locations of this reinforcement bar, it seems to be functioning as the compression reinforcement bar, as the compression strut of the concrete drain. You can imagine that there will be power foundations here. Assuming the entire concrete drain is simply supported onto the foundations, this will form a conditions as if a truss and imaginary truss conditions, and there will be a regions of compressions, which is known as the compression strut. I believe by having the reinforcement here, this will strengthen the compression strength of the concrete at this region. Correct me if I'm wrong, feel free to comment. Now coming back to the requirements. When it comes to the drainage design, there are certain requirements that normally the local council as well as the other authorities will check during the submissions. Those are the additional requirements on top of your design. Even though your design ends up not requiring those, but the local authorities still enforce them. This will be due to the other considerations and concerns by the local authorities. Normally they have a checklist that you need to fulfill during the submissions, and there will be personnel checking through your submissions in accordance to the checklist as well. The local authorities have made this to be transparent, that you know the requirement so that you can do the self-check, make sure all the requirements are fulfilled before submissions. While checking your submissions, not only they check your design, they will look into your proposed development and design in a broader context. In terms of the development, not only restricted to your own site, there may be considerations for the overall regional development. Now, while submitting your design, as far as you're concerned, probably the drain size for your catchment areas is sufficient. It might end up the local authority requesting you to increase the size of your drain, as they foresee the following development might need to discharge their waters into your drain, or there could be other considerations. For that, they will provide inputs and make requests for you to modify your design, addressing their concerns. Therefore, it is important to work alongside with the local authorities for any development and strike a balance between the commercial considerations as well as the public safety and sustainable development in the broader context.